Hey guys, welcome back. This episode is called Crankshafted, which should be pretty obvious after the last episode why, but we'll take a look at this crankshaft, show you why we're not going to use that for the 1000 horsepower build. We'll have a look at the cylinder heads and where we've got to with those, and we'll take a look at the flow bench that we're building with a bit of help from the mad scientist. So just measuring the big end journal that we've seen in the previous episode. So this is where cylinder number 1 piston rides, and we can see, you can visually see that it's already smaller than where piston number 2 is going to ride, but we'll just get that data. So 51 to 52.78, so 52.78 in comparison to, you can see how much I've got to open that up just to get that on. .33. The other thing that I wanted to point out here, you see this balancing hole in the crank. That balancing hole has been drilled very close to this journal. So even if we were to try and grind this back and go for an oversized bearing, you're just taking more meat away from that stock crank. And being that we want to use a stock crank, it's not ideal that we want to take any more meat off it whatsoever, let alone when it's got a balancing hole in it here. And you can see how deep that balancing hole goes as well. So the more we reduce that radius, the more we grind this crank down, the thinner that wall is going to get. So we're not going to use this, not for a 1000 horsepower build. It'd probably be fine for a stock rebuild, but yeah, we're not going to reuse that for this one. So this is our exhaust ports. So with the exhaust ports, what you can see that black carbon ring there. That carbon ring, that's kind of a burn that's been created from the exhaust. And then the outer ring here, that's telling you where your exhaust gasket has been sitting. So there's no point taking that floor out any further, because as the hot gases come up from your cylinder on your exhaust stroke, they want to hit this roof and they want to travel out through your exhaust. So what we're going to do is we're going to take it wider, and we're going to open these ports up to where that black ring finishes, where that black carbon ring finishes, and we're also going to raise the roof as well. So all of these exhaust ports will have the roofs raised and just widened to match the gasket. One thing to note as well is there's no point in doing any of that if you're going to bolt an exhaust header to it that's this size. So you've got to match whatever you do here to your exhaust as well. Otherwise, all that's going to happen is your exhaust is going to flow out of this chamber, and it's going to run into a brick edge around here, and it's going to create a lot of turbulence in that area where the air is just trying to escape. So just grab the old gaskets just for that visual representation. You line up those bolt holes, and now you really can see that black carbon ring, and why that black carbon ring is there, because of that gasket sealing surface. So that's what we're going to remove. We're going to remove the meat in the casting on the sides of the ports and raise the roof. Like I say, no point in really touching the bottom too much. We'll give it obviously a good clean up. But the exhaust gases themselves are going to want to, hot air rises. It's being forced up from the piston. It's going to come out of there, and we just want to make that as smooth a transition into the exhaust as possible while maximising the airflow. These are the intake runners. So intake being that the air is coming in through the manifold, and then it's travelling in through here down to the valve and into the cylinder. So again, anything that we can do to remove restriction on that air getting in, then the more airflow that we'll get through there, and we'll see that when we do the bench testing. Your injector, that's why you have these cathedral port intakes on the LS1, because of where the injector is positioned. So your fuel is injected directly at the valve, this sort of trajectory. You can see where the gasket lies. So we'll take those gaskets, we'll lay them across here. We'll see exactly where they sit, which should be pretty much where you can see these witness marks from the other manifold that's been on here. And then we'll just start to increase and clean up all the scale that's inside these ports without going anywhere past that sealing surface. And that leads us into the combustion chambers. So with the combustion chamber, what you'll see is here's your valve seat, where your valve actually seals up against your head. So what you can see though is from your valve seat, it actually raises up here, exaggerated like this. It raises up, and then that's just part of the casting, and then out to your inlet. This is your inlet valve, and this is your exhaust valve. So what we're going to do with these, just to maximize the flow through here, is we'll just take these bowls, we'll just blend those out to about, I think the rule of thumb, something like 88% of your valve seat diameter, your inner valve seat diameter. You don't want to go too thin, especially with the exhaust ports, because if you go too thin with the exhaust ports, that heat can actually expand the casting so much that your seat falls out. The percentage is slightly different for the exhaust, but we'll talk about that when we get to the actual porting. Back here as well, you've got your valve guide. Now your valve guide sits in a big boss, and where that boss is, you've also got a bit of a swirl ramp there. So we want to take some of that edge off. I'm sure if you have a look at some pictures of some ported heads, and you look at the valve guide and the swirl ramp, and you'll see what's been done there. You'll get a good picture of that. But when we actually do the porting, you'll see it done. You'll see how I do it anyway. So yeah, opening up our exhaust ports, removing some of the restriction that's created by the valve guide boss. We'll open up these bowls, and we'll open up our inlet runners, and we'll just keep mapping that as we progress through the head. This is how we'll regulate the vacuum that's being pulled through from the blower vat. That is plumbed in through here, through this cabinet. Now out of here we'll be taking two pressure readings, one static and one in line, through the use of a Pt.4 tube. That gets plumbed up into cylinder heads, and we'll act like the vacuum being pulled through by our cylinder. We'll pull that through at 28 inches of water, which is the vacuum measurement that we'll be using, which is pretty standard for all cylinder head measurements. So I just wanted to say quickly that while all this information is pretty cool, it might also be over the top for some people. Really, if you want to get that same kind of performance out of your cylinder heads, you don't need to go and build a flow bench. That's just something that I'm doing out of interest, and hopefully other people find it interesting too. But you can just take your castings, your 241s, to a machine shop. They'll either hand port them, or many places have got CNC programs that are written for these cylinder heads. So they'll just put that casting into the machine, and it'll spit out the kind of flow numbers that we want to achieve here anyway. So yeah, hope you find this interesting, but by no means don't let it become sort of overwhelming information. If it's not your cup of tea and it goes into a bit too much detail or it's too time consuming, just find yourself a local porter and you know, you can get the performance out of the heads that you want to relatively quick and easily. That's it for now, guys. Thanks for tuning in. Just wanted to give you an update on where the build was at. Hope you found some of that interesting. For now, I need to crack on with the next part of the job, and for that, I need to connect a spark plug to a barbed fitting to a manometer. And why? I guess you'll find out on a future episode of Miller's V8 Garage. Thanks. Cheers for tuning in. See you soon.